This is the process of acoustic transduction, the process that allows us to hear. Compression waves move through matter into our ears. The characteristics of the sound wave determines how we will hear the sound. Higher frequency leads to higher pitch, a greater amplitude leads to louder sounds, measured in decibels, and the quality of the sound determines timbre. The compression waves are deflected by the nooks and crannies of the pinna, or the outer ear, down the auditory or ear canal, and into the tympanic membrane, commonly known as the eardrum. The eardrum relays the vibrations from the compression wave through the ossicles, the three teeny ear bones known as the hammer or malleus, the anvil or incus, and the stirrup or staples, and down into the cochlea. The vibrations then cause the oval window, the membrane covering the opening of the cochlea, to vibrate and disturb the fluid within the cochlea. Then the cilia, teeny hairs on top of the basilar membrane, which is in the cochlea, vibrate and transduce the vibrations into auditory signals. These signals are sent down the auditory nerve to the thalamus in the brain, which then relays them to the auditory cortex in the temporal lobe, and we perceive these vibrations as sound. So overall, the sound is collected in the outer ear, concentrated in the middle ear, transduced in the inner ear, and perceived in the brain. There are two different theories that together explain how we hear pitch. The first is called place theory, and it states that when different parts of the cochlea vibrate, different pitches are heard. The problem with place theory is that there are more pitch sounds than can fit on the basilar membrane. For example, the pitch 100 Hz exists in real life, but it does not exist on the cochlea. The second theory, frequency theory, states that the rate of the impulses traveling up the auditory nerve match the frequency of the sound and thus allows us to determine pitch. For example, if it traveled this fast up the auditory nerve to the brain, it would be one pitch, as opposed to if it traveled this fast up the auditory nerve. The problem with frequency theory is that the neurons can only fire 1,000 times per second, yet there are pitches higher than 1,000 Hz. This is fixed with the Volley principle, which says that neural cells alternate their firing, so combined they can reach above 1,000 firings per second. Neither theory is right nor wrong, yet they both help us to understand how we hear pitch.